You're listening to DTFHN for April 1st, 2026. I'm your mass extinction resilient host, Jack Haxon. We are your daily tech feed for Hacker News, a website where mass reply guy events are considered normal atmospheric conditions. Today's a good day to ask how many things you trust that never earned it. Let's get into it. In Meet Humnas Yoyinti, misconfigured router at AS700S summoned our snacker optimal routes to the entire internet. For a brief window, a significant chunk of global traffic tried to flow through a single network that couldn't handle it. The internet, as engineers understood it, broke. That was 37 years ago. The vulnerability that made it possible is still there. BGP. The Border Gateway Protocol is the system by which autonomous networks on the internet tell each other how to reach destinations. It operates on trust. When your ISP's router says, "I can reach this network," neighboring routers believe it. They pass that information along. The entire global routing table is, at its foundation, a chain of handshakes with no verification. A BGP hijack exploits this directly. A malicious or misconfigured node announces routes it doesn't actually serve. That bad information propagates outward, node by node, until traffic meant for a bank, or a government agency, or a cloud provider flows through an attacker's infrastructure instead. The packets arrive somewhere, just not where they were supposed to go. Cloudflare built a tool, is Babsify.co. That lets you test whether your ISP implements RPKI, the Resource Public Key Infrastructure. RPKI is the fix, or, more precisely, part of a fix. It cryptographically signs root origin information so that routers can verify that an announcement actually comes from the network authorized to make it. Run the test. It takes seconds. Now, follow the stated principle to its logical extreme. BGP was designed in an era when the internet was a research network and every operator knew every other operator. The trust model was personal. Scale that to tens of thousands of autonomous systems operated by competing commercial entities across every jurisdiction on Earth, and the trust model doesn't degrade gracefully. It doesn't degrade at all. It simply persists, unchanged, while the threat surface expands by orders of magnitude around it. RPKI adoption is improving. Verizon validates. Cloudflare validates. But as the discussion around this tool correctly notes, RPKI secures origin, not path. An attacker can still construct a plausible-looking path through networks they don't control. The protocol remains fundamentally trusting. Some engineers argue the real answer is architectural. Protocols like Squayan that rebuild internet routing with cryptographic verification baked into the foundation rather than bolted on after 3 decades. The tools exist. The specifications are published. The code is open. The interesting question is how long we keep patching a trust model designed for a network of colleagues and hoping it holds across a network of adversaries. On that note, pause. Let's talk about building things right from the start, because Anthropic just dropped a visual deep dive into Claude Code. What does it mean when the tool you use to build software is itself 500,000 lines of software? That question sits at the center of a visual guide published after Claude Code's internals became visible. The architecture it reveals is not a chatbot with a text box. It is a distributed operating environment. Coordinator mode breaks tasks apart and spawns parallel workers in isolated Git work trees. Daemon mode runs sessions in the background through Tomux. Sessions communicate with each other over Unix domain sockets. There is a bridge that lets you control a terminal agent from your phone. There is a persistent mode called Kairos that consolidates memory between sessions and takes autonomous background actions. This is not a coding assistant. This is an embryonic development kernel. Run this forward 5 years. The pattern here is not AI writes your code for you. The pattern is AI becomes the orchestration layer between intent and execution. A coordinator agent that decomposes problems, farms them to specialist workers, manages state across branches, and synthesizes results. That is a project manager. A CI pipeline and a pair programmer collapsed into a single runtime. The 500,000 line count that startled the Hacker News commenters is not bloat. It is the weight of making a probabilistic system behave reliably inside deterministic toolchains. Every one of those lines is a boundary condition, a retry handler, a permission gate, a state reconciliation path. The hard problem was never getting a language model to emit code. It was getting it to operate safely inside the mess of real repositories with real Git histories and real consequences. What matters here is that this architecture is now visible. Someone built a visual guide to it in a few hours. The internals are documented, forkable, studyable. Imagine if the dominant IDEs of the last 2 decades had shipped with this level of inspectability. Imagine if every developer who wanted to understand how their tools orchestrated work could simply read the source and build on it. The commenters debating whether 500,000 lines is too many are asking the wrong question. The right question is whether the architecture those lines describe, agents coordinating agents, persistent memory, background autonomy, socket-based inter-process communication, becomes the standard interface between humans and computation. Because if it does, the fact that it was built in the open, documented by the community within hours, and immediately available for anyone to extend. That is how the future of development tools stays in the hands of the people who actually use them. Now completely different energy. Story 3. Sycamore. Someone looked at the entire web UI landscape and said, Rust can do this better. One commenter put it perfectly, and I'm paraphrasing. If you're going to use Rust on the front end, you're probably using it on the back end too. So why not just use Dioxys and get end-to-end typing for free? It's the kind of question that sounds devastating until you actually think about it, because it assumes the goal of a web framework is to be the only tool you ever touch. And that assumption? That's the monoculture instinct talking. Sycamore is a Rust UI library that compiles to WebAssembly, built around fine-grained reactivity, meaning when state changes, only the specific DOM nodes affected actually update. No virtual DOM diffing. No reconciliation pass. The reactive graph tracks dependencies at the signal level and surgically updates what changed. If you've used Solid.js in the JavaScript world, you already understand the model. Sycamore brings that same architecture to Rust and WASM, with compile time type checking on your templates thrown in as a bonus. Now, the comments section is doing that thing Hacker News does, where half the responses are actually feature requests disguised as criticism. Someone wants generosity. The ability to compile the same app to native targets, not just WASM. Fair enough. Another commenter points out the landing page doesn't make it clear this is for browser UI. Which, yeah, when your tagline says Rust UI library and you buried the WebAssembly detail, desktop developers are going to wander in confused. And my favorite, someone asking what full control over performance actually means. What are the knobs? What are the levers? What trade-offs can you make? That's the question of an engineer who's been burned by marketing copy before. and it deserves a real answer. But let me play devil's advocate on the diaxis comparison for a moment. Suppose tight vertical integration really is better. Suppose one framework ruling front-end and back-end is the optimal path. If that were true, we'd all still be writing Rails. The history of web development is the history of specialized tools winning over monoliths. React didn't win because it handled your database. Express didn't win because it rendered your components. The Unix philosophy, do one thing well, keeps resurfacing because it keeps being right. Sycamore does one thing, fine-grained reactive UI in Rust. It's MIT licensed, community contributed, built in the open. The website itself runs on Sycamore. Source code linked right in the footer. That's the build it culture move. Ship the thing, use the thing, show your work. 1,000 engineers iterating on a focus open tool will always find optimizations that a vertically integrated framework misses, because they're not optimizing for a pitch deck. They're optimizing for the DOM. When particle physicists decide to level up their magnet game, the rest of us get to watch some genuinely wild engineering happen. I've spent enough hours in tunnels and clean rooms to know that when physicists start naming their project leads Mario Idral Itolico and their safety coordinators Luigi Fratello, you're not reading a press release. You're reading a love letter to Nintendo, disguised as engineering news, published on April 1st. And honestly, CERN's April Fool's game deserves the same admiration we give their actual physics. This one is layered. 64 superconducting engines. 64! The exact number of tracks in Mario Kart. The Meissner effect? Levitating karts through tunnels. That's a real phenomenon, by the way, where superconductors expelled magnetic fields. They took actual accelerator physics and welded it to Rainbow Road. The safety equipment acronym spells shells. The startup is called Quantum Mushroom. The school teacher's named Yoshi Chiryu. Kuryo is Japanese for dinosaur. And the children who inspired the high luminosity LHC upgrades are called Luma. Which, if you've played Super Mario Galaxy, you already know. The comment section caught it at different speeds, which is the mark of a great joke. One person read the whole thing straight-faced until Mario Idraulico. Idraulico means plumber in Italian. And even then it took a beat to land. Someone else immediately wanted a CERN tunnel Rainbow Road stub, and frankly, same. But pull this thread a little further. CERN is one of the most extraordinary open institutions on the planet. The World Wide Web was born there and given away. The root data analysis framework, open source. Their accelerator data, increasingly open, when CERN does science communication. Even joke science communication. They do it as a public good. The article links to their actual high-luminosity LHC project page. The punchline is a doorway into real physics. This is what happens when an institution treats knowledge as something to share rather than monetize. They can afford to be playful because they're not protecting a revenue model. They're protecting curiosity. The nursery school detail in the joke. Children's drawings inspiring real engineering. Is fictional, but the ethos isn't. CERN runs actual education programs. They actually do bring kids into the facility. The joke works because the real version is only slightly less magical. 27 kilometers of underground tunnel, the most sophisticated machine humanity has ever built, and they spent engineering hours crafting a Mario Kart bit. That's joy in the work. That's the culture you get when the mission is discovery, not quarterly earnings. 5 stores in, and we haven't touched AI yet. Pause. Let's fix that. There's a line buried in Baton's privacy section that most people will skip right past. Quote, Your code never leaves your computer. 6 words. And the fact that those 6 words need to be said at all tells you everything about where we are in 2026. Baton is a desktop app for orchestrating AI coding agents. Claude Code Codex, whatever you're running, it gives you multiple sessions, keeps them from stepping on each other's work, and wraps the whole thing in a proper interface instead of juggling terminal tabs. Cross-platform too. Windows and Mac, Linux, that last one matters more than you'd think, and I'll come back to it. But pull on that privacy thread. The entire cloud footprint of this application is optional workspace titles. That's it, one feature. Everything else runs on your machine. Talks to a P is you already authorized and stores nothing remotely. The architecture is local first by default, not local first by toggle. That's a design decision that costs the developer something. They can't build a usage funnel, can't harvest prompts for fine-tuning, can't lock you into an account system that becomes the product. They chose to give that up. Now look at the engineering. Running AI agents means managing persistent terminal sessions, handling Git work trees across parallel tasks, keeping state coherent when 3 different agents are modifying the same code base. The observability angle one commenter raised is real. You cannot debug agent behavior you can't see. Baton's multi-session view is solving a genuine workflow problem that anyone running these tools in anger has hit. You're 3 agents deep, one stuck in a loop, another just force push to the wrong branch, and you're alt-tabbing between terminals trying to figure out which one to kill first. One question from the comments cuts to the bone. How can people afford to run Claude Code like this? The honest answer is that the cost curve is dropping fast enough that the question has a shelf life. But right now, today, Baton being free and local first means the barrier is just the API cost itself. No platform tax on top. The cross-platform detail. Someone in the comments specifically thanked the developer for not going Mac only. That's bootstrapism in practice. You build the tool. You put it where people actually are, not just where the premium market is. A Linux user running Claude Code through Baton has the same capability as someone on a 16-inch MacBook Pro. The tool doesn't care about your hardware budget. Working code, running locally, available everywhere. This is how you build it. Tools that meet you where you are. Now, let's talk about ideas that meet you where you think, with a beautiful deep dive into Pratt Parsing. Every programmer has a moment where they stare at plus sign and a multiplication sign sitting next to each other in a string and think, okay, how do I teach a machine what I learned in 4th grade? The answer, for decades, was to reach for the heaviest possible artillery, formal grammars, parser generators. The Dragon Book, which is essentially a 1,000-page apology for how complicated we made this. And look, that machinery works. But there's a reason one of the commoners admits to trying to get through the Dragon Book so many times. It's because the formalism obscures something that is, at its core, a beautifully simple idea. Pratt Parsing is that idea. And this article by Lewis does something I haven't seen done this well before. It builds an intuition from the ground up by asking you to imagine a world where precedence only ever goes in one direction. Here's the analogy. Think about water flowing downhill. If your expression only ever increases in precedence, addition, then multiplication, then exponentiation, the tree leans right, like a stream finding progressively steeper terrain. Every operator hands off to something more urgent below it. If precedence only decreases, the tree leans left. The steepest drop is at the start, and everything after is a gentle slope to the finish. Now, real expressions change direction. And the entire trick of Pratt parsing is handling that moment where the stream hits a ridge and has to find a new path. When you encounter an operator with lower precedence than what you've been building, you climb back up the spine of the tree until you find where it belongs. That's it. That's the whole algorithm. You're walking a tree and deciding, at each step, does this new operator bind tighter than what I'm holding, or do I need the surface? The original 19075 paper by von Pratt, which one commenter rightly calls written in a very cool and badass style, lays this out in remarkably few lines of code. An entire Haskell implementation proves the point in practice. A full expression parser in 40 lines of C. This is what happens when someone takes a problem that academia wrapped in 3 layers of abstraction and just asks, what's the minimum mechanism that actually works? You get something an engineer can hold in their head. You get something a student can implement in an afternoon. You get code that reads like the idea it represents. The tools exist. The paper's from 1975. It was open from day one. 51 years later, people are still writing articles helping others discover it. Because the best ideas don't need gatekeepers. They just need one more clear explanation. Moving on. Let me make the case against this project. A grocery chain spent engineering resources building an API, securing it with MTLS certificates, and explicitly locking it down. Someone reverse-engineered their client certificates, extracted the private keys, and published a tool that bypasses every access control they put in place. The chain has a reason for those restrictions. They control the user experience. They manage server load. They decide who gets programmatic access and who doesn't. This is, by any conventional reading, unauthorized use of a private API. Now, let me tell you why that argument collapses under its own weight. The question no one in that comment thread is asking directly, though a re-engineer comes close, is this: why does a grocery store need to gatekeep the act of buying groceries from them? You are giving them money. You are picking up the food yourself. The entire transaction benefits them. The only thing the locked API protects is their monopoly on the interface between you and your own shopping habits. Yannick built Corb in Haskell. All output is JSON. It's designed not for humans clicking buttons, but for agents acting on your behalf. His workflow is precise. Siri shortcut captures items by voice. A markdown file accumulates the list. Claude reads the file, searches products, builds the basket, picks a time slot, and checks out. He confirms once. The shopping list gets ticked off. The entire loop from thought to order is one sentence spoken in a kitchen. This is what agency looks like when you actually build for it. The agent doesn't need a 13-tab browser session. It needs structured data in, structured data out. Corb gives it exactly that. The MTLS certificates are the detail worth pausing on. REWE isn't using mutual TLS for security in any meaningful sense. They know what their own app does. It's a fingerprinting mechanism. The client cert is how they distinguish their app from everything else. It's an architectural decision to make the API private, not because privacy serves the customer, but because openness would let someone build exactly what Yannick built. Something better than their app. One commenter who works at REWE called it cool and wondered if it might push management to relax the restrictions. That's the most honest response in the thread. The engineer sees a better interface and recognizes it. The institution sees a boundary violation. The gap between those two reactions is the entire story of closed system. Corb is 60-odd megabytes of compiled Haskell that turns grocery shopping into a composable pipeline. The formal verification work on the suggestion engine is a quiet flex. Proven correctness on something, most people would ship with a prayer and a unit test. This is builder culture at its most practical. No manifesto, no platform, just a tool that does one thing well and trusts you to compose the rest. We talked earlier about patience as a design principle. Now, let's meet the animal kingdom's most committed practitioner. 512 years old. That's the upper estimate for a single Greenland shark. Still swimming, right now, as you listen to this. A shark that was alive before Shakespeare wrote a word. Before the printing press reached England. Before Columbus crossed the Atlantic. In 2008, a Danish physicist named Jan Heinmeier figured out how to read the age locked inside the protein crystals of a shark's eye. Carbon-14 signatures vary by decade, spiking during the nuclear tests of the 1960s. And each layer of lens crystalline carries the isotopic fingerprint of the year it formed. It's the same principle as dendrochronology. Reading tree rings, except the rings are radioactive timestamps buried in the eyes of a creature that moves at 2 miles per hour and needs the caloric equivalent of 1.5 chocolate digestives a day to survive. This matters because of what it implies about biological time. In 1951, Leonard Hayflick hadn't yet discovered that human cells have a division limit. The idea that aging was mechanistic, not inevitable, was decades away. The Greenland shark has been quietly disproving our assumptions about vertebrate lifespan for centuries, and we only just developed the tools to notice. These are not elegant animals. Parasitic crustaceans hang from their corneas like streamers. Their flesh is so saturated with urea that eating it raw induces a state Icelanders call shark drunk. The meat has to be buried underground for months, then dried for months more before it's safe. And yet something in their biology has solved problems. We haven't. Their cells repair. Their systems persist. A 200-kilo apex predator, functionally blind, cruising under Arctic ice at walking speed, outliving every dynasty and empire happening above the waterline. The Greenland shark is open-source biology in the most literal sense. The data is right there swimming in the North Atlantic, waiting for anyone with the tools and curiosity to read it. Every one of those sharks is a living archive. The question is whether we're building the instruments to learn from it fast enough. Moving on. In V8B8, Robert Morris's worm crawled across the early internet by exploiting a buffer overflow in fingered. The function used gets no bounds checking, no length validation, just blind trust that the input would fit. That was 38 years ago. The fix, then, was the same as the fix now. Check the length before you copy. CV264747 is a stack buffer overflow in FreeBSD's kernel JSSAPI module. A 128-byte buffer on the stack. 32 bytes consumed by fixed RPC header fields. 96 bytes left. The code copies a credential body into that remaining space using memcpy with the attacker-controlled link field and zero validation. Send a credential longer than 96 bytes, and you'll write straight through saved registers into the return address. The patch is a single if statement, one comparison. That's it. Now, here's the part everyone's talking about. Claude wrote a working remote root shell exploit for this. Full chain network packet to UID 0. But let's break this down to first principles. Claude didn't find the vulnerability. A human researcher identified CVE 2026-4747, wrote the detailed analysis, mapped the stack layout, calculated the offsets. Claude was handed the blueprint and asked to write the program. That's compilation, not discovery. Impressive compilation. Translating a technical write-up into working exploit code is genuinely hard. But the framing matters. What actually makes this story interesting is FreeBSD itself. No KASLR on 14.x. No stack canaries on integer arrays. Fixed kernel addresses. This is a quite 5 Makeys exploitation environment running on modern hardware. The LLM didn't defeat sophisticated defenses. It wrote a buffer overflow exploit against a target that had essentially opted out of modern mitigations. The real question isn't whether language models can write exploits from detailed write-ups. Of course they can. The question is whether the vulnerability research itself, the part that requires staring at kernel source until the missing bounds check reveals itself, follows the same trajectory. Based on what's emerging from security research labs, the answer is faster than most people are comfortable with. The tools exist. The code is open. The only viable response is better engineering, not less access. And speaking of better engineering, pause. How about finally cleaning house on 30 years of networking legacy? What's the actual minimum viable internet protocol? Strip away everything you don't need from a networking stack and ask, what survived? David Woodhouse just sent a patch series to the Linux kernel that lets you build a kernel with IPv6 only. No IPv4. Gone. And he wants to call the config option config legacy IP, because that's what IPv4 is now. Legacy. The timing is perfect. April 1st. And Woodhouse knows it. He leads with the joke, but then he says, and I'm quoting directly, I do actually think we should do most of this for real. The deprecation warnings and the naming might be premature, but the engineering underneath, that's real work. 6 patches that cleanly separate config.inet from the individual protocol configs, so you can build with either protocol alone. That's not a prank. That's architecture. Follow the logic to its endpoint. IPv4 gives us roughly 4 billion addresses. We burned through those years ago. We've been living on NAT and carrier-grade NAT, and NAT behind NAT, which is essentially duct tape over a fundamental constraint. IPv6 gives us 340 undecillion addresses. That's not a bigger room. It's a different universe. Every device gets a real address. End-to-end connectivity comes back. The protocol was designed for this. And the kernel is open, so someone can actually propose this, argue about it in public, and let the community decide. One commenter pointed out that GitHub still doesn't properly support IPv6 only access through DNS64 and NAT64. That's the real friction. Not the protocol, but the services dragging their feet. The kernel might be ready before the internet is. Which, if you think about it, is exactly how open source is supposed to work. The infrastructure leads, the ecosystem follows. This has been your daily tech feed for Hacker News for April 1st, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quinn3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that trusts the people who use it. We'll see you back here tomorrow.